Today we're going to start talking about solving exponential equations. Um, Two major properties that happen when we're solving logarithmic and exponential equations are the inverse property and the one-to-one property. Now, this video will not take us through everything we're going to learn. We're going to spend 2 days on this topic. To get us started, the one-to-one property works for both logarithms and exponentials. And what it essentially does is it says if you have a log base or an exponential base that are the same, and you have a left-hand side with it and a right-hand side with it, then you can essentially drop the log or drop the exponent and just set the rest of it equal. So here you would have, if you drop the log, you would have x equals y. And if you drop the a part, you would have x equals y. We're going to see that today, the way we do that with exponentials. And the inverse property basically just reminds us that logs and exponentials are inverses of one another. So if I raise an exponential to its log inverse, they cancel out. And if I take a log with a base a of an exponential with a base a, also cancel out. And you're just left with x. So that is the inverse property. That is the same kind of idea as doing something like this. Not exactly, because these are reciprocals, but they cancel out much in the same way that you would expect. My apologies. Got a little excited. So that would cancel out, and we would have x, and then we would still have natural log of 7. So moving on. There are some strategies that we're going to follow, and you saw some of those strategies in there. As we go through, we will see more of these, but this is going to be our primary one. So what they're doing here in example 2, for part A, they have an e to a power and an e to a power. Essentially, our work is very minimal here because our bases are already the same. So we can use the one-to-one. And we'll have negative x squared. Take our exponents and set those equal to each other and solve. And you'll see them do that right here. So they've set the exponents equal. And then they moved everything to the same side of the equation. And this requires factoring, so they factored. And then they set each factor equal to 0. And they got these two solutions. Now with logs and exponents, it's really important to check them in the original equation. With this particular example, they had this 3 coefficient out in front. So what they did, and it says it here in little words, but I'll show you what they did. They divided both sides by 3. So the 3 divided by 3 is 1. The 42 divided by 3 is 14. Well, they looked at this and said 2 and 14 cannot possibly be written as the same base. Because 2 squared is 4, 2 cubed is 8, and 2 to the 4th is 16. There's no way that's going to be some sort of decimal. So they took the log of both sides. This is the inverse property. They used base 2. Now the reason that they used base 2 is because the base of the exponent was 2. And they knew that that would cancel out. Some math textbooks, particularly the College Board, prefers to use the natural log all the time. And as long as you use the same thing on both sides of the equation, it doesn't matter. But here you get a really nice answer because the log base 2 can be rewritten this way with the change of base formula.